Hi friends, welcome to the study culture. Here I came with the bending moment and shear force diagram topic which may helpful to you, and here coming to the topic bending moment and shear force diagram in the strength of materials subject. Detailed explanation of shear force and bending moment diagram. Mostly we are using three types of loads: point load, UDL load and uniformly varying load, means triangular load. Point load. For the point load, what will be the shear force diagram? How it will be? I will show you. For point load, shear force diagram will be in rectangle, uniform and in straight line. Bending moment diagram for point load: rectangle and inclined straight line. For UDL load, shear force diagram will be in rectangle, inclined straight line. And bending moment is square parabola. For UVL load or triangle load, shear force is square parabola, and bending moment diagram is cubic parabola. In diagram also I will explain. Cantilever beam subjected to point load. How will be the shear force and bending moment diagram? This is the beam, load, length L. Shear force diagram will be in rectangle and bending moment diagram will be in rectangle, inclined straight line, like this. This is W, this is L and this is WL. For simply supported beam subjected to a point load, simply supported beam which is subjected to a point load W. This is L and from this to this is A, remaining is B. Shear force diagram will be rectangle and rectangle, WL, WB divided by L, WA divided by L, like this. And bending moment diagram will be inclined straight line, WAB divided by L. Beam subjected to UDL. This is a cantilever beam subjected to UDL W by unit length. This is L, and shear force diagram will be like this triangle WL. Bending moment diagram is little inclined parabolic WL square by 2. Simply supported beam which is subjected to a UDL. Simply supported beam subjected to UDL. W by unit length. This is L. Shear force diagram will be like this, WL by 2, WL by 2. And bending moment diagram will be like this, WL square by 8. Cantilever beam subjected to UVL. Cantilever beam subjected to UVL of maximum intensity at fixed end and 0 at free end. Cantilever beam subjected to UVL like this, maximum at fixed end zero at free end. Here 0. Length L. Shear force diagram is like this, parabolic. And the bending moment diagram is cubic. WL by 2, WL square by 6. Simply supported beam subjected to UVL. Simply supported beam UVL load. This is length L. Shear force diagram will be parabolic and cubic. Parabolic here, cubic here. WL by 3, WL by 6. And bending moment diagram is like this, WL square by 24. This is simply supported beam subjected to a UVL load. Cantilever beam subjected to end moment. Cantilever beam subjected to end moment. Considering cantilever beam subjected to end moment, considering length L. Shear force diagram is only line and bending moment diagram is rectangle. This is M. For simply supported beam, which is subjected to its span, simply supported beam which is subjected to a moment in its span. Simply supported beam subjected to a moment in its span. This is simply supported beam. In the span there is a moment. This is A length, this is B length. L means A plus B. Shear force diagram is, this is the shear force diagram, M divided by L. Bending moment diagram is, this is the bending moment diagram, MA divided by L and MB divided by L. Take a example problem. At any section in the BC, considering X section, shear force diagram for BC. Shear force for BC. What is shear force? We know that upward direction is negative, downward direction is positive for shear force. So, plus 500 Newton. Bending moment for BC, minus 500 into X. That means we don't know this length. So, length X and load 500 Newtons. For these, in the bending moment, sign is negative. So, minus 500 into X. So, we don't know X at minimum X. So, X is 0. Bending moment also 0. At X maximum, that means 0.5 meter. 0.5 meter. So, what is the bending moment for 0.5 meters of X? Minus 500 into 0.5, that is equals to minus 250 Newton meter. Next, at any section in the A and B, considering this also X, shear force for AB, that is equals to 800 plus 500, that is equals to 1300 Newtons. Bending moment for AB, minus 500 X minus 800 into, we don't know this distance. So, we can consider this as a X and this as a 0.5 meter. So, 0.5, X minus 0.5. So, minus 1300 X plus 400. At X is equals to 0.5. For minimum means 0.5 X. Then what will be the bending moment minimum? Minus 1300 into 0.5 plus 400, that is equals to minus 250 Newton meter. Bending moment diagram at maximum, bending moment at maximum, that means X is equals to 1 means 0.5 plus 0.5 1 minus 1300 into 1 plus 400 that is equals to minus 900 Newton meter. Remember, for BC shear force is less 500, for AB shear force is 1300 Newton. For bending moment of BC is minus 250 Newton meter, for AB minus 900 Newton meter. Remember all these. Draw the bending moment and shear force diagram. Shear force diagram. Draw the bending moment and shear force diagram. 800 Newton, 500 Newton, 0.5 meter, 0.5 meter. Considering this as A, B, C, and the whole length is 1 meter. Remember previous values. For BC, shear force is 500 Newton and bending moment is minus 250 Newton meter. For AB, shear force is 1300 Newton. Bending moment is minus 900 Newton meter. For this value, we have to draw diagrams. First of all, take shear force value. Shear force values are both two are positive. That means only in the upward direction. In this direction. First, BC. For this span, BC, shear force diagram for at BC is 500 Newtons. Considering this as a 500 Newton, this is rectangle. And next 1300 means this as a 800 Newton, like this. This is 1300 Newton. This is the shear force diagram for this problem. And bending moment diagram. We can observe this bending moment diagram is negative. Bending moment diagram is in negative. So this is the span. For negative values, we are drawing the downward. This is 250 and this is 900. Both are negative. This is the whole problem, and in next class we will discuss about another two examples of bending moment and shear force diagram problems. That's it for today. We'll meet again in the next topic. If you liked the video, give it a big thumbs up and subscribe my channel. Bye bye.